Now let us study the last of the chemical reactions of ethers, that is hydrolysis. After that we will study the uses of diethyl ether and finally about crown ethers. So let us begin with the fourth one, that is hydrolysis. We have already learned about the action of HI, action of cold HI, action of hot HI and electrophilic substitution reactions. So let us now begin with hydrolysis. So hydrolysis involves the action of dilute H2SO4. Our first example is dimethyl ether, that is CH3O CH3. Now to this, when we add dilute H2SO4 under pressure and heat, that is we basically react it with water. So the CH3 that we can see here, it reacts with OH to produce CH3OH. The other part that is left is, which is CH3O and H, they also combine together to form CH3OH. In this way, we get 2 CH3OH, that is methanol. So we can say that an ether on hydrolysis produces alcohols. The next example that we can study here is ethyl methyl ether, that is CH3O C2H5 plus H2O. Now again, this is done with dilute H2SO4 at heat and under pressure. Now C2H5 will react with OH to form C2H5OH, that is ethanol, whereas CH3O will react with H to form CH3OH. In this way, when we combine the red box, we can see that there is ethanol C2H5OH, and when we combine the green boxes, we get CH3OH, that is methanol. So the products that we get are CH3OH, that is methanol, and C2H5OH, that is ethanol. So summarizing this, I can say that ethers, when they are made to undergo hydrolysis reaction in the presence of dilute H2SO4, produce alcohols. Moving on to the next part, that is uses of diethyl ether. Diethyl ether is used as an industrial solvent for oils, fats, etc. It is also used as a solvent in the Grignard's reagent reaction, which we have already seen. Also, it is used as a refrigerant. Now, a mixture of diethyl ether and ethyl alcohol is known as natellite, and this natellite is used as a fuel, which is basically a substitute of petrol. So now let us study about crown ethers. Now this is the structure of the first crown ether. This is known as 18 crown 6. So what are crown ethers? Now it was Charles J. Pedersen who discovered macroscopic polyethers, that means they contain more than one ether, which are the organic compounds with molecules containing large ring of carbon and oxygen atoms, called as crown ethers because they basically resemble crown. The crown ethers are named as N crown M, where N is the total number of carbon as well as oxygen atoms. So the 18 that you see here is the total number of carbons as well as oxygens, and M is the number of oxygen atoms in the ring. So that means we can say that in the structure that we have here, we have 6 oxygen atoms and 12 carbon atoms. The very first crown ether to be synthesized was the compound 18 crown 6. So this was about crown ethers, and this is where I end this module.